Finally, after 30 years in the making, a successful launch into space, 50 successful deployments, 1 million miles traveled from Earth, months of cooling to near absolute zero and calibration, it has delivered its first full-color science-quality images.
Space telescope is, in a way, a little like Galileo's first telescope. Wherever Galileo pointed his telescope, he made major new discoveries. Look at the moon, you find mountains and craters. Look at Saturn, you find rings. Look at the Milky Way, you find it is littered and composed of stars.
If you could look back in time, when would you look back to? Early man, the time of the dinosaurs, or the birth of our planet?
We like to say telescopes are like time machines, and of course the reason that this is possible is because light takes time to travel. So the street lamp across the street takes a teeny tiny fraction of a second for the light to reach your eye. The light from the sun takes about 8 minutes to reach the Earth. So in essence, we're seeing the sun as it was 8 minutes ago.
Now, a new telescope that's more powerful than anything that's ever been sent into space is looking at some of the farthest and oldest objects yet. It's called the James Webb Space Telescope, or JWST, and it can see back to the beginning of the universe, when the first galaxies started to form and emit light after the Big Bang.
One of the great things about telescopes like this is they're really designed to see the entire universe. So all the way to 13.5 billion years into the past, all the way to our cosmic backyard of the solar system, and everything in space and time in between.
Finally, after 30 years in the making, a successful launch into space, 50 successful deployments, 1 million miles traveled from Earth, months of cooling to near absolute zero and calibration, it has delivered its first full-color science-quality images. These images showcase the telescope's powerful instruments and offer a preview of the science projects to come.
These first images really do signify the start of science operations. We have over a year of observations already planned, some really exciting things that we already have designed to do in the first year of operations.
The hope of scientists is to uncover the greatest mysteries of the universe today.
We would like to observe galaxies as far away as possible.
Red giant stars in the disk of Andromeda.
How stars, galaxies, planets, etc. formed, and that really helps us understand how we fit in.
So we have all of these very specific, questions that we've planned to try to answer, and I think we'll for sure answer those.
Liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
In 1990, the Hubble Space Telescope successfully launched aboard the Space Shuttle Discovery. It's been serviced by humans in space 5 times, allowing it to be one of the longest running and most expensive science missions to date. For more than 30 years, through its powerful imaging system, it's changed our understanding of the universe. Galaxies, nebulae, and star clusters have been seen like never before.
The Hubble Space Telescope grew from the idea that by putting an observatory into space above the atmosphere, you could get much sharper pictures without that blurring that the Earth's atmosphere brings.
Perhaps one of the most well-known images came from what's known as the Hubble Deep Field. Instead of looking at previously known galaxies observed from ground-based telescopes, they pointed Hubble at a relatively empty part of the sky and took hundreds of long exposures over a 10-day period. then combined them. This first image changed the way humanity saw the universe. Almost all of the roughly 3,000 objects captured here is a previously unknown galaxy.
So Hubble has actually helped us illustrate the evolution of the universe from the first cold gas and dust, which was lying around millions of years after the Big Bang, and how that coalesced and agglomerated and swirled together to form galaxies full of shining stars. So that's one of the great successes of Hubble. So to follow on from that science and see the birth of the first galaxies, we need a bigger telescope, and we need one that operates in the infrared, and that's the James Webb Space Telescope.